don't tell me water in the swimming pool has color because of tiles. You can go to an indoor swimming pool, it'll still be blue. And with a white tile, it'll still be blue. Another case I'll tell you, if somebody takes you to a swimming pool which doesn't have a marking and tells you this is 3 feet and that side is 15 feet, jump into 3 feet. You'll say, no, no, this is 15, that is 3 without marking. You can tell the difference, isn't it? Which side is deeper, which side is shallower, without looking at the marking. How do you tell? The deep side is deep blue. The shallow side is very light in color. So you cannot say because the tiles are same in that pool. So what's the reason? Is water blue or is something wrong? When I say water is colorless, what is happening? What is the experiment? When I say something is colorless, what's the experiment you are doing? What's the process of saying this is colorless? An object is colorless, an object is red color. What is the process?
Pass the light and see what other color it reflects. Just pass the light through it and see what other color it reflects.
No, just I am seeing this. I am not passing light. I am just seeing it. I am saying this is colorless. What is happening? What is the process? No, put light passing through. What else is happening other than this object? There is an object. I am seeing it. So what do I do? That's a process. What do I do for seeing? What do you do for seeing? You detect an optical signal through your retina. That is your detector. Then signal gets processed to brain, and the brain tells you whether there is color or not. So at the end of the day, like a camera clicks a picture, anything which you see is your camera, is your eyes, and that's what you are going to detect the signal. Yes? And now if you understand this process and you ask yourself a question, is your eyes have infinite sensitivity or there's a limit to the sensitivity for your eyes? Eyes definitely have a limit to sensitivity. They are not infinitely sensitive. If they are infinitely sensitive, we don't need any detector or spectrophotometer or anything. We will keep developing detectors for space applications and other things. Because every detector has its own strengths and weakness. The moment you understand the experiment in terms of its tools, and the experiment to see is the ability of the eyes to detect and brain to process. And if you understand that eyes are not infinitely sensitive, then your experiment conclusions will change because you know the limitations of your tools. And that's what the emphasis. Most of the times you do experiments and computer gives numbers which are ridiculous, but you still use those numbers. Like AFM you do. And it says surface roughness of 0.01 nanometer or 0.1 nanometer. A lot of you must have reported those numbers. You use a molecule and try to get an information which is some molecular. That is just not possible. It's a number which is the computer has calculated and given to you. So if you know that eyes don't have infinite sensitivity, if you see something colorless, if that is an experiment, what will be the conclusions which are valid? Tell me the conclusions which are valid for an observation. Using my eyes, I see this, no color in that. What could be the conclusions for this experiment? Which are complete conclusions of the experiment. What could be, how you read the experiment you understood. You understood the experiment, you understood the tools. Now you have to write the conclusion of this experiment. What will be the conclusion? You can have one conclusion, object is colorless. So your conclusions will be either the object is colorless or it has a color which is below the threshold of detection of eyes. And that cannot be challenged. For this given experiment, these conclusions are complete. Either one of them you have to prove it, you have to do further experiments. So water actually has blue color, but the color is so weak that your eyes are not in a position to detect it. And you know what is color? What is color has different strengths. Dark color, light, very light, very light, very light, very light, 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 light. Can go on as an homeopathic medicine is nothing but an infinite dilution of the molecules. It's a molecular level mechanism, if somebody understands. So same thing, no detection limit will detect those molecules in that low concentration. Same thing, color can also keep on diluting. How do you now prove that water has a color? Increase the color strength. What is the color strength depends on? What is that relation? In high school, what's the principle? What's the color? Color related to? It's called Lambert-Beer law. Absorption is proportional to epsilon, concentration and? So what's the concentration of water? So can I increase the concentration of water? Yeah, boil it out. Yes or no? Can I increase the concentration by boiling it? No, because you're just decreasing the volume. Concentration doesn't change that water. You can only dilute it. How do I decrease the concentration of water? Add anything to this concentration will decrease. So I can't increase the concentration, but I want to make it more stronger. What can I do? You can increase the path length. And that's exactly what happens. When you go to a swimming pool or somewhere else, the path length of the water increases. And above a certain threshold, path length increases to a level that it has enough color for your eyes to start seeing it. And that's where you start seeing the blue color in water. So for half a feet, 1 feet, very difficult to develop. You require a little larger. And a lot of you have also read it wrong, that the color of the water is because of that sky. There's a very famous wrong information which is going around, at least in India, wherever I go. The first thing they say, I have been stopped actually in the lectures by senior professors saying that this information is wrong. Raman actually proved that the color of the water is because of the color of the sky. Somewhere this got written in some of the books, and blindly everybody is believing it, including some of the professors. And if you go back and look at the history, Raman was the one who actually proved that. So the story is right. Rayleigh and Raman were on a ship. That is the story. Okay. Rayleigh was the one, remember Lord Rayleigh? He was the one who gave the hypothesis that color of the water is because of the reflection of the sky. Okay. Raman was the one who said, no, that's not true. And the experiment was done, they both went on the ship. That's what the discussion happened. And Raman did an experiment. He took a polarizer. Okay, I don't want to go into physics, but when the light falls on a water which is dielectric and comes out, if that's the light which comes out, it's horizontally polarized light. So if I put a polarizer in front of it, which is 90-degree cross polarized, that light will get completely blocked. If the color is because of the sky, if I put a horizontally polarized 90 degree, that color should block. And they did that experiment. And through the polarizer, they still saw water as blue. Which clearly means that's not the reflection of the light which is coming, which is polarized. It is the inherent property of the water. And then this path length. So that experiment was right, story is right, but the conclusions drawn are wrong. And once it got written, it's just going on and on in a lot of cases. So remember that story is right. Color of the water is blue, it absorbs in near 900 as the first overtone, but very weak absorption, and then it keeps accumulating, and that's what, at a certain path length, it builds up the color. Okay. So remember that thing, for any experiment, any observation, you need to understand the experiment as a whole process. When I say process, which means, what is the object, what is happening, and what is the detector. Don't assume that one thing is missing. If one thing is missing, there's no experiment. If you do an experiment with your eyes become detector. If you do an experiment with your hand is a tool. Whatever at the end, the moment these tools are in place, you can explain anything. So if at the same thing, if I tell, there are 10 people standing between me and you agree or not agree? Answer the 10 people standing here. Yes or no? Why? I said it. Eh? Answer 10 people are standing here. Why you don't believe? So if you don't see, you don't believe. You been believing your teacher for so long, water is colorless? So if you don't see, you don't believe. Yes or no? Yes? Say loudly. Yes or no, doesn't matter. I know dinner is waiting, but still. Yes. Yes or no?
Yes.
Yes? There's an air between me and you. Yes or no? How come you just told me you don't believe, you don't see? You feel it. You don't observe it. You feel it. Feeling is an observation, isn't it? Yeah. You require, so what you have to tell, any sense you get, you can sense it. Vision is one of the sensors you have. That's not the end of the sensors which you have. Your body has infinite sensors. So, any one of the sense does not trigger a response, then only you say that thing is absent. Okay? So now air, and I'm giving you a clue for my question which will come after dinner. Air, which is there, is not visible. There are certain things which are visible, certain things which are not visible, but they're all there. What's the criteria of seeing something? Think about it, we'll come back to that later. Understand now? I just want to trigger this process that whatever you do, what is the reason behind it? You see this, you see this, you see me. We don't see air. Where does it cut off? What does happen that suddenly something becomes, and the moment you understand these, you will understand a lot of things on that. Okay? Remember that? I'll come back to that a little later. You all play cards? Let's see how many of you never seen cards? How many of you never seen this such interesting objects like dice? What I'm trying to now show to you is, dice you see? Is there anybody who has never played with the dice? Never hit other person, never broke one, never throw one? All of you? Yes? Have you ever paid attention to what it is? It's a cube with 6 faces. Yeah? Some 12 edges, I don't know how many. Yeah? And corners and this. Beyond that, can somebody tell me beyond that? One. That's okay, raise your hand, let me see. Answer is a cube with that many edges, that many faces, number 1 to 7, 1 to 6. Anything beyond that? Every day, all your life you have been playing with this. 1, 2. Add value to my statements, another value. 2 students, and plus 1 who have attended my lecture earlier. Isn't it very funny? Something all my life I have spent, never even noticed it, never even worried about looking at it. Strange or not strange? All your life you have been playing with it, doing with it, and still not paid attention. That's quite, just like apple falling down every day. What could be special?
Some of the opposite faces.
Some of the opposite face, or take any dice anywhere. Some of the opposite face have to add to 7. If you are putting money anywhere on a die game, make sure you check the die. If it is not 7 opposite face, don't put money, because that's a gimmick die. And I'll come back to this again. Such mundane things. Every day we do that, we don't pay attention to anything. Same thing, cards. How many cards in a pack? How many suits? Which are those? Club, heart, spade and diamond. And each suit has how many cards? Ace to king. Very smart kids. Yeah? So if there are 52 cards, how many pairs are there? 26 pairs? When you shuffle the card, how many pairs you can break? 1 pair at a time? Yes? And if you look at the cards and look at them carefully, it should not take much time to remember all the 26 combinations, 26 pairs. If that is the case, if I remember 26 pairs, whatever shuffle I do, I should at least remember some of the pairs other than 1 or 2 which breaks. Yes? So that's what the experiment will do. We shuffle them. I will do this. You say stop at any time. You tell me where you stop, 1 card, and I'll tell you what's the pair card there is. Let's try this experiment. Who wants to say stop? Yeah? I can go further up and down, your choice. Convinced? Just tell me what this card is. 6 of club. Do you have jack of spade? Yeah? Jack of spade. Not believing? We'll try once more. You want to say stop? She doesn't believe. Your friend. Okay. Shweta is going to say stop. Yeah? I can go again. Okay. I can still do it. Sure? Just tell me when did you stop me? Hey, club, party girl. You like club? Is it 10 of club? Tell me, I can see the cards from backside. Don't tell me I can see the cards from backside, isn't it? There are marked cards. You have to find reason, isn't it? They are not marked cards. Believe me, and I'll show you. Anything is happening in front of you.
Last one you can do on the last one and put it.
Like this.
The last one and put it on the upside.
This one.
Yeah, then you can remember that two pairs with one pair, and you should think the probability to get separated is very much low.
Yeah, that's what I'm saying. So, but that's what I'm saying. So, when you shuffle, you only break one pair. But I have to remember all the 26.
No, you want to remember only one.
But then she doesn't need to stop there.